Hi, this video will look at the advantages alloys have over metals, the uses and properties of the alloys brass and bronze. Also, we will look at aluminium alloys, gold alloys, steels, including mild steel and stainless steel. If you need more help, click the links in the description below. Metals have many useful and desirable properties. However, the use of any particular metal will most likely depend upon its physical and chemical properties. Some of the common physical properties of metals are shown on screen. For more information on metals and metallic bonding, check out the separate video on metals and metallic bonding. The links are in the description below. However useful metals are, you should be aware that any particular physical property of a metal is fixed and cannot be changed. This will ultimately limit the use of a particular metal, since the particular property of the metal may not be suitable for the job or need at hand. But luckily, this is where alloys come in. Now, alloys are simply mixtures of metals and sometimes non-metal elements. Alloys are simply made by taking the main metal in the alloy mixture, melting it, and then simply adding one or more metals to this molten metal, then stirring the mixture and allowing it to cool to form the solid alloy. As an example, consider the layers of metal atoms present in a metal. Now, if these layers of metal atoms are pulled or pushed, then the metal will stretch because the layers of metal atoms are able to slide over each other. However, by mixing in another metal, it is possible to make it much more difficult for the layers of metal atoms to slide over each other. This in turn will make the metal stronger and harder. As an example, consider the alloy brass. Brass is made by mixing the two metals, copper and zinc. The image shown on screen shows the structure of brass. You can clearly see this time that the presence of the larger zinc atoms will make it much more difficult for the layers of copper atoms to slide over each other if the same pushing and pulling forces are applied. The presence of these zinc atoms will make the alloy much harder and stronger. Although the properties of the brass can be changed by changing the composition of the alloy mixture. For example, brasses with high copper contents tend to be soft with a golden appearance, while high zinc content brasses give an alloy which is harder with a more silvery appearance. The melting points of the brass will also depend upon the composition of the mixture. Now, alloys such as brass, where one atom has been substituted for another, are often called substitutional alloys. Common uses of brass include musical instruments, costume jewellery, plumbing fittings, electrical plugs, locks, hinges and gears. Another substitution alloy of copper is bronze. However, this time the copper is mixed with the metal tin. Typical bronzes consist of around 88% copper and 12% tin. Like brass, bronze is a very corrosion resistant alloy, and it is much stronger than the copper metal that is its main component. The main uses for bronzes are in the manufacture of hardware fittings such as screws, handles and locks. It is also used to make statues, ships' propellers and fittings for boats and yachts. Aluminium is a lightweight metal, but it is relatively soft and not particularly strong. However, it can be alloyed with a mixture of different metals and even some non-metals to form a variety of alloys. One of the first aluminium alloys produced was duralumin. Now, duralumin is formed when aluminium is alloyed with approximately 4% copper and a small amount of magnesium, manganese, iron and the non-metal silicon. Duralumin is a strong lightweight alloy. It is corrosion resistant. It is stronger than aluminium, but unfortunately it is also heavier. Because of its properties, duralumin is used in the manufacture of aircraft parts, bicycle frames, marine parts and even car wheels. There are many different types of aluminium alloys, and depending on which metals are alloyed with the aluminium, It results in the formation of different types of aluminium alloys with different properties and many different uses. Pure gold is often called 24 karat gold. Now, gold is a metal used to make jewellery because of its beauty and corrosion resistance. However, 24 karat or pure gold is far too soft to be used to make jewellery. However, gold can be alloyed with other metals to make it harder and more suitable for use in jewellery. However, adding these other metals will affect its colour. For example, rose gold is 75% gold with 2.5% silver and 22.5% copper added to it, and this alloy of gold has a pinkish tint, while white gold contains gold mixed with the metals platinum or even palladium, and as its name suggests, it has a silvery appearance. However, this alloy of gold is hard and scratch resistant and is very suitable for use in making jewellery, although it is expensive. 24 karat gold is pure gold, while 18 karat gold is an alloy containing 75% gold with added zinc and copper metal. This alloy of gold is commonly used to make jewellery since it is harder than pure gold and also more scratch resistant. 9 karat gold is another common alloy of gold. It contains 37.5% gold with added copper and zinc. It is cheaper than 18 karat gold because obviously it contains less gold, but it is not as hard or as scratch resistant or as corrosion resistant as 18 karat gold. Iron is not a particularly good metal to use for construction or building simply because it is not particularly strong. It stretches easily and worst of all, it undergoes corrosion or rusting. Iron is much more useful if it is alloyed with the non-metal carbon to form the alloy steel. Now, there are many different types of steel, each being produced for a particular use, perhaps in the construction, transport or for some commercial application. The simplest and cheapest steels are called carbon steels or mild steels. These are alloys of iron which contain between 0.03 and 0.5% carbon. They are malleable, ductile and strong in tension. These low carbon steels are used to make items such as fridges, washing machines and car parts. High carbon steels have a much higher carbon content, up to 2% and sometimes even a little higher. These high carbon steels are stronger than low carbon steels, but they're more brittle. High carbon steels are used to make items such as tools, chains, saws and drills. Finally, alloy steels are steels which contain other metals such as chromium, nickel, titanium, tungsten and vanadium. Alloy steels which contain chromium and nickel are better known as stainless steels. Now, these steels are expensive, but they have excellent corrosion resistance and are very strong hard steels. They are used to make high quality tools, cooking utensils such as knives, forks and spoons, car exhaust systems and sometimes even cars. The DeLorean sports car, for example, best known for its role in the Back to the Future films, was unusual because its body panels were made of stainless steel and were never painted. They were just simply polished. Steel is an interstitial alloy. This is an alloy where small atoms such as carbon or boron are able to fit into the gaps between the metal atoms. The carbon atoms are able to form bonds to the iron atoms and so prevent the layers of iron atoms from sliding over each other. This will of course make steel stronger and harder than the metallic iron. Now, in stainless steel, not only do we have small carbon atoms mixed through the giant lattice of iron atoms, but other atoms such as chromium and nickel are also present. The chromium and nickel atoms will substitute for the iron atoms, just as in a substitution alloy, and the carbon atoms will go into the gaps between the larger metal atoms. So stainless steel is described as a substitution stroke interstitial alloy.